So I told somebody that I'll be doing some of the questions for science, and here we go. Now for science, the questions are actually coming from this book. Okay, this is a PSLE Science book from EPH, okay, which I found really useful. Why? Because at the back of the answer sheet, they actually have a breakdown. Let me show you what they have. Okay, they have a breakdown of all the different types of questions that has appeared. For example, they will tell you that in 2018, 7% of the questions were about diversity of materials. 3% of the question was about matter. How about water and change of state? That is about 7%. You know, so and they even make a average, so you can really tell, you know, what are the things that you need to concentrate on. But as I mentioned in my other videos, it actually doesn't matter. It doesn't matter because it's really random. I mean, if you buy this book and then you go and study all the statistics over there, they're all over the place. So honestly, don't bother spotting topics for PSLE Science. Okay, so what we're going to do is we're going to go straight into the questions. You can see over here my favorite writing board on the this side, okay, on this side of the screen, so you can take a look. I'm also trying to type a bit bigger so that you can see. Okay, so without further ado, let's try to go and answer some questions. Okay, so hopefully by the end of this video, how I would use this video is something like an archive. You know, like I don't know how long the video will be because there are like 20 over questions here. Is there 20? No, there are 21 pages of questions. So hopefully they are, I think I'll probably take like an hour, okay, or lesser than that to go through every single one of them. So they're all over the place, you know. Initially I wanted to do it topically, but I think it's a bit too difficult to find like which one is from where. So just do everything. Anyway, most importantly, they have this keyword called explain. Most of the questions, they use this keyword called explain, so you just gotta explain. It really doesn't matter which topic they are from. Okay, so without further ado, let's move on. You know, this one is really so comfy, and I'm beginning to realize that I'm speaking a bit slower. So let's pick up the pace and do some work. Okay, so let's take a look at question number 1. So when air becomes very cold, suddenly cracks appear on the pavement. As you can see over here, these are the cracks appearing on the pavement. So I think this is like concrete. So this is concrete, and warm soil. So explain how the change in temperature caused the pavement to crack. Usually I like to talk about the start-end technique. Okay, I like to use the start-end technique because it's 2 marks, so there's quite a bit of stuff to explain. So how the change in temperature caused the pavement? Now where is the change? You see at the top is cold, at the bottom is warm. So there is a change, or there's a temperature difference. So we also know that when it's warm at the bottom, what happens when things are warm? There's expansion, not just expansion. Then when it's cold at the top, we have contraction. Okay, so what does this mean? This means that this pavement is probably being contracted at the top, and then it probably expand at the bottom. That causes the thing to crack. So I think science-wise, it's not too difficult to be able to piece all these things together. But usually for PSLE Science, the problem is the English part. Okay, I don't know about you or your kid, but a lot of students, they have problem piecing all this little information together. So what we do is we use a simple start-end technique. What do you mean by start-end? So at first, you talk about what you see at the start. So what do we see at the start? You see the cold wind at the top, and then there's a warm soil at the bottom. So we go along this line that the temperature difference cause the pavement to contract at the top and expand at the bottom. Okay, so this caused this difference in expansion and contraction caused the pavement to crack. Okay, so this is how I would answer this particular question. Okay, this is how I would answer this particular question very quickly, right? So of course you can go and explain more about the warm soil. The warm soil causes the bottom to expand, or the cold wind at the top causes it to contract at the top. I think you can talk about that, but you see the start end technique is easy because at the start you just copy whatever is here. Change in temperature. So start, you talk about the change in temperature, and then you fill in what's in between. What's in between is that the change in temperature caused the contract at the top, expand at the bottom, and therefore this difference caused the pavement to crack. That's it. So the end part is the pavement to crack. So you gotta talk about why the pavement crack at the end. So 2016, Booker B. Let's take a look at the next one. Okay, so the next question, Xiaoming conducted an experiment using the setup shown. Two beakers were identical and contain hot water at the same temperature. So same temperature. After some time, found that the temperature of water in B was higher than that in A. So both you have hot water. Okay, hot water here. And then after that, this one, temperature higher, temperature lower. So we have air here. Can you see that? And then, well, this thing isn't covered. So obviously, because this thing is covered, it's insulated. Okay, so it's being insulated. So if it's being insulated, which one do you think loses heat faster? Okay, which one loses heat faster? Of course, setup A lose heat faster. You see, at the end of the day, we want to say that the temperature of water in setup B was higher than A. Okay, the one in B was higher than A. So A probably lost heat faster. So right now, lost heat faster. But why did it lose heat faster? Okay, this is the air. So I will note down. These are like mental notes. You don't really have to write down. But I just want to write it down to show you what I'm thinking about. So the air is poor conductor of heat. Okay, so here you got a poor conductor of heat. Here you don't have this poor conductor of heat, so it loses heat faster, and therefore the temperature of water in B was higher. Okay, so what is the start? The start is just to identify that this side setup B, we have the air that acts as a insulator. Okay, so in setup B, there is a large glass container that has air which acts as a poor conductor of which, okay, the air is a poor conductor of heat. A poor conductor of heat. Hence, the hot water beaker lose heat slower than setup A. Therefore, the temperature was higher. That's it. Okay, so I'm aware that there are actually many different people say you need like different techniques, heuristics for science, all this stuff. Honestly, I think just use logic, just use logic, because P6 students, there's really a lot of things for them to remember. If I give them like a template, like you remember this template, remember that template, I think there's like too many things. So I mean, in terms of math itself, heuristic, there's already a lot of things to remember. Science, So just understand the concept, find some of the key things that's going on, and yeah, like over here, got air. So just note that down and then just word it properly. I think you should be fine. Okay, you should be fine. Okay, after I type out this, I'd like to take a look at the answer, and see if that's correct. Yeah. So it's about there. Okay, so let's just move on. So this is 2016. We are doing physical sciences for 2016. So animal Q below lives in co-characteristic layer of fur based on the explain. So can you see that it's always explain, explain this, explain that. Explain how the thick layer of fur of animal Q would help to keep it warm. Love this question. Because the start is thick layer of fur, second part is keep it warm. So this is how we'll answer. The thick layer of fur. Okay, that's the start, no? Because it's being mentioned here. Thick layer of fur. How to keep it warm? Keep it warm is the last part. So a thick layer of fur has pockets of air, which is a poor conductor of heat. Okay, that helps to prevent heat loss. This keeps animal Q warm. Basically, the idea is that the thick layer of fur has pockets of air, which is a poor conductor of heat, and I'm just repeating the whole thing. Okay, prevents heat loss, keeps animal Q warm. Short and sweet. Don't go. I really don't think you have to talk too much. Yep. Okay, so they talk about, I'm reading the answer, by the way. Okay, I'm reading the answer. I think it's perfectly okay when you're doing revision, just to check that it is correct, because I don't want to give you the wrong stuff as well. Okay, so Jia Xian used the setup shown to investigate the magnetic force between two magnets A and B. There's A and B over here. Why? Explain why. I can see this. This is the reason why I came up with the previous video about PSLE Science and spotting trends. And there's no trend, but the key thing is you need to be able to explain. And the fastest and the best way for you to be able to learn how to explain stuff is to explain using start-end technique. Okay, so explain why magnet A stay at the same position above B as shown in diagram 1. Repulsion. Okay, so it's about magnetic force. So explain why magnet A stayed in the same position above magnet B. So I will say that both magnet A and B are, so both. Okay, so I mean the idea is about repulsion. So sometimes a lot of things are very obvious. Like for example this one. Of course, repulsion, magnetic force of repulsion. Okay, but how to write it out? That is the key thing. So why magnet A stay in the same position above magnet B? Okay, as shown in diagram 1. So both, sorry, let me just rephrase that. Okay, we want to be a bit more specific. So both the poles, sorry, the like poles of magnet A and B are facing each other. This causes them to repel, and the force, the magnetic force of repulsion, repulsion causes, typing, causes magnet A to stay on top. Okay, so you want to talk about forces, magnet, like poles repel, go up. You see, these are the ideas in your head. Just write them down. Write them down. Okay, just write them down. You should be pretty okay. Next one. Now, of course, here we are assuming that you understand magnets, like poles, repel, okay, unlike poles attract. So if you don't understand that, you gotta go back to your basics, okay. Next, Jiaxian pushed magnet A towards B as shown. He found that he needed to push harder as the distance P decreased. Okay, why? So he needed to push harder is because the closer the two magnets, the stronger the force of repulsion. So, oops. Oh god. So the closer. Okay. Okay. This is getting out of hand. Wait a minute. Okay. So the closer the two like poles, the stronger the force of repulsion. Type too fast. And hence, Jiaxian needs more force to keep the magnet down. That's it. Okay, so let's take a look and see if that is what they want. B, magnetic force increase between experience a greater repulsive force. Okay, so the key is greater repulsive force. Just put it in. Okay, greater repulsive force, and hence he needed more pushing force to keep it down. Okay. Next, what's that? Okay, the toy ball G floated above a base because of magnetic force as shown. A second toy ball H had a rod through its center. So magnets both are made of the same material and the same size. So Jiaxian rotated both balls with the same amount of force. So let's rotate both same amount of force. You see, sometimes, you know, these science questions, right, it's like a test of your comprehension, you know. Yeah, after reading here, I got like a bit lost. So he rotated, because the story is a bit long. So here you rotate, here you also rotate, okay. So explain why H stopped rotating around the rod H, but G continued to rotate many more rounds before stopping. Okay, so first let's see what's the difference between this thing here and this thing here. Second toy had a rod through its center connected to a base. Both were made of the same material and same size. Okay, so the difference is this. Can you see? There's magnets here, and then there's no magnets. Okay, so there's no magnets for the one on the right. Okay, so offhand, what's the first thing that comes to your mind? Why this thing stops? Okay, why does this thing stop here? The first thing that comes to my mind, of course, is friction. Okay, it's got to do with friction. That means over here there's less friction. Here there's no, here there's no friction, but here there's friction between the ball and the base. So friction causes opposes motion. There's less friction. Sorry, there's less friction here, and there's more friction here. Okay, so explain why H stopped rotating. So the start is to identify that for diagram 4, over here, there is friction. This is friction somewhere here. Whereas for the other one here is less friction. We cannot say no friction because there's air resistance. As it's spinning around, there's air resistance. So, but here is obvious as friction. So we want to state this first because the examiner just wants you to state that. So the ball H. Hi. Now, what's going on? H. Ball H is resting on the base and has and because it's resting on the base, which causes more friction than for G, which is floating. Okay, so the friction, no force, causes for H to stop faster than for G. Okay, so identifying friction here, and there's no friction here. So H is resting on a base, which causes more friction than G, which is floating. Hence, the frictional force causes H to stop faster than ball G. Okay, let's take a look and see, is that what they're looking for? Yeah, there was friction between H and the rod. It's in contact. Thus, part of the kinetic is double. Oh, okay, so they are looking at more kinetic energy being used up. Okay, so I would you have to add kinetic energy. Okay, because when it's moving, yeah, it does have kinetic energy, but it's in 1 mark. So yeah, so to answer this properly, we have to. So the frictional force causes H to stop faster than G because as more kinetic is used to overcome friction. Okay, that's it. That's it. Next one. Let's take a look at the next one. So I would say that it's more of an experience. You know, how we learn science and how to answer science is more of experience gaining. Than rote learning. For primary school science, it is experience. I guess it's the last question for 2016. Okay, let's take a look. Okay, so Hui-Ting's mother bought a new pot that's a layer of material that prevents food from sticking to its... Okay. So Hui-Ting's mother stopped her when she wanted to use a metal scrub to clean. Explain how the metal scrub will damage the pot. Okay, so the metal scrub will damage the pot because this metal scrub is harder. So it's going to cause scratches. Okay, so the key idea here is about it being harder. So we say that the metal scrub is harder than the pot and will how the metal damage scratch will cause something wrong with the keyboard, cause scratches when scrub on it. Okay, let's see if that's what they are looking for. Yep. Okay, that's it. Scratch. So the keyword is harder. Now these are physical properties. So for example, hardness is a physical property. What does hardness mean? Hardness is the ability to scratch, whereas there's also strength. Okay, strength, but this is about hardness because it's scratch. So if we did want to find out the hardness of two materials H and F, we use a rounded object made of 4 cylinders. What? Some of these experiments, you really have to see what they're trying to do. Okay, so the results of the experiment are shown below. Rounded object of G, rounded object of material G. Okay, so you got two different types of material. One can go in deeper, the other one cannot. So list materials FGH in increasing order of hardness. Okay, so obviously G is the harder one because G can scratch H, G also can scratch F. Okay, but G according to the experiment, can scratch H more than F. Why? Because when material G comes in, it can scratch 3 mm, this one only 1 mm, but none of them can scratch G. Did you see that? So least in increasing order of hardness, so I would write increasing means the least hard to the hardest. So the least hard is H followed by F, then G. Why? Because G can scratch H deeper than F. None of H and F can scratch G, which makes it the hardest. That's it. Next. Alright, so you get 2 marks for that. Okay. 5. Any other stuff here? Question 41. Is that the last one? Oh yeah, this is one more. Okay, so this is energy question. Let's take a look. Okay, so Hazik used the setup shown to find out the type of bulb affects the temperature of surrounding. Data logger. So temperature sensor wooden box with a lid. Bulb R was lit up. He covered the box and recorded the temperature. 10 minutes. Removed the bulb. Left box uncovered. Okay. So T is like the hottest. Because after 10 minutes on 36 degrees Celsius, the box change in the to show the energy changes in the bulb. Okay, so for the bulb to light up, obviously it needs electrical energy. So electrical change to light bulb. They already give you the answer, no? Light bulb, so light energy, and here this is pretty obvious. What are they measuring? Temperature, so heat. That's it. Next. Okay, so give a reason why Hazik left the box uncovered for 15 minutes before repeating the experiment. Okay, so why leave it for 15 minutes before repeating? Now, if he didn't leave the box uncovered, what will happen? There'll still be heat inside, right? So then he cannot start at 25 degrees Celsius. So give a reason. The box, now give a reason is also like explain. So we start with the box was uncovered for 15 minutes to ensure the temperature, ensure the heat escapes and temperature goes back to 25 degrees Celsius. This ensures that the experiment is fair. That's it. Okay, ensure the experiment is fair. Next one. Which bulb RST light up its room to reduce energy use? So R, okay, R. Why R? Wait. Do that again. So bulb R. Bulb R. Why? Why? Okay, so we want to reduce energy used by the air conditioner. Why? Because bulb R, according to the table, it uses a less heat. Okay, it's not that it uses it; it releases the least amount of heat according to the experiment. Okay, so what's so good about releasing less heat? So Hazik does not have to use energy, use too much, use more energy from air conditioner to cool down his room. This saves okay, we don't have to talk about save energy. Okay, so about R, release the least amount. So he does not have to use more energy from air conditioner to cool down his room, hence using less energy. That's it. Okay, I think we are done with the 2016. Let's take a look. Are we done? So there. Oh, still one more. Let's see. Very interesting questions, huh? Okay, so inflated balloon was placed in the toy rocket as shown. When air was released, the toy rocket moved upwards. After moving, no more air, and explain why the target was still able to move from point G to and then found. Oh, okay, this question is actually quite difficult. Yep. How come? You see, at G it has used up all the energy, but then it can still move up. In physics, they call it momentum. It's actually under the secondary school science. Okay, so it still has momentum. Why was it above G highest point then fell down? Because it has momentum. It's got to do with energy, kinetic energy. So let's answer that. Oops. So at point G, there was kinetic energy. Okay, so at point G there was kinetic energy causing the rocket to move upwards. Okay, so there are actually two parts. One, it couldn't move up, and then at point H it fell down. So at point H, all the kinetic energy was converted to gravitational energy, potential energy. Okay, and hence it started to fall because there's no more kinetic energy to push it up. Understand? No more, not enough kinetic energy to push up. So once it reached the point H, which is at the maximum gravitational potential energy, but zero kinetic energy, so it started to fall. Okay, let's see if that's what they are looking for in the exam. Yep, that's right. Okay, so they are looking at kinetic energy. Why it still moved is because there's still kinetic energy. In physics, it's called momentum. Because there's still kinetic energy which hasn't been used up, so it will be used up later on. Okay, so the diagram shows the path of a balloon. Well, if there's no wind, why the balloon does not move in a straight line? So it's like there's no wind. Why the balloon does not move? Okay, so suggest a reason. So why doesn't it move in a straight line? First of all, when something doesn't move in a straight line, that means there are forces pushing it left and right. Okay, so your answer would have to include things like forces. So there's no wind in the room, but there is air in the balloon. So we talk about the air in the balloon escapes from the outlet. So what do you need to explain? First, why it doesn't move in a straight line. That's one. So we talk about the air in the balloon escapes from the outlet in different directions. Okay, so the the moving air in different direction causes the balloon to move in different directions as well. Okay, so it's 1 mark. I don't think there's like a lot of things to talk about. Okay, so they are not looking at that. They're actually looking at the shape changes. The shape changes. So my idea was that the air coming out is moving in different direction, but the key idea here is that it is about the shape of the balloon. So I'm actually wrong. Huh? You see that? Now, once again, I'm not here to give you the perfect answer. I'm here to show you that it's okay to how to answer questions, and if you got it wrong, well, all you have to do is to just change it. Okay, it is perfectly okay. I've seen this. I probably said this before. I don't remember how it works. So the idea is that air comes out here. Well, it probably I don't think I would get like the whole thing wrong, but the correct answer is that the balloon changes shape, and then because it changes shape as it's traveling through the air, the different shape of the balloon causes it to move in different directions. Okay, so that's the idea. So I don't think I will get the whole thing wrong. I'll probably get like half correct. Okay, so don't let that stop you from attempting questions, and because I'm not letting that stop me from answering questions and making a video out of it, it's perfectly okay. Okay, so the idea is that the different shape. Okay, I think this is one more. Yeah, there's one more. Question 44. Okay. So what type of material are the contacts made of? Mass of 40 kilo. Okay, so there's a ride at the amusement park. The mass is too high, therefore a child can board around if it's mass. So if it's too heavy, this part will connect. So connect and it becomes a closed circuit, and therefore this thing will light up. So for that to happen, metals, conductor of electricity. Okay, what are you looking for? Yeah, it's metals. Why? So metals can conduct electricity and cause closed circuit when they are in contact for the light bulb to light up. Okay, next. So engineer says the design is not safe. It says it will be safer the light bulbs when a child stands on it. Give a reason. It's not safe. So we want it to be. Why is it not safe? If the light bulbs when a child stands on it. Okay, so we gotta study why. What is this about again? When the mass is too high, it can only board if it's less than 40. Setup A is used to detect a child with mass of 40 or more. So it's not safe. Okay, I've got plenty of comical reasons why it is not safe. I'm not sure if I can share that with you. I'm going to share it anyway. So comical reason number one, you get this boy to stand here if, because it's standing on some kind of a spring, he might just fly away. Okay, like if the string is too strong, it stand on it, you can feel it flies away. Okay, that's just comical reason number one. Comical reason number two, maybe he get electrocuted. I don't know. So anyway, So yeah, you see, as you're answering questions, all these weird things comes into your mind, and then you gotta use logic. And okay, do you think that is the answer for the little boy to fly away? I don't think so. Yeah, I don't think so. Okay, so let's see what. Okay, let's try and think logically. So this is an engineer. He says the design is not safe. It will be safer if the bulb lights up when a child of acceptable mass stands on it. The child of acceptable mass stands on it. Seriously, I have no idea. I can only think of a comical reason. Okay, so we're gonna leave it there first. So how should setup A be changed to allow a child who is 50 kg below to board the ride? Now we want to change it so to allow a child who is 50 kg and lower to board the ride. 50. So basically, we're going to increase the weight. So to increase the weight, just add. So increase the strength of the spring. Now, when it increases the strength of the spring, you need a heavier child to stand on it. So when you increase the strength of the spring, it will take a heavier child to compress it. Okay, hence allowing a child who is 50 kg below to board. Okay, so now I'm really curious what's the answer to this. Let's take a look. Science teachers, contrary to what you think, science teachers don't have all the answers. Okay, we don't have all the answers, and I am perfectly okay with that. You have to be okay with that as well. So we learn, but setup is not safe as one spring may be compressed more than okay, what is the reason? So it's not about the child flying away, which I think would be really comical. It's about this one may be compressed. Like for example, if the boy doesn't stand in the middle, he plays a fool like what all little boys likes to do. Let's say you stand closer to this side and the spring, okay, it stands too close to this side. Over here, the spring gets compressed more at this side and then he topple and falls. Okay, valid reason. Okay, that's it. Okay, so that's for B. And C, is it correct? Yeah, make it stiffer, make it stronger. That's about it. Okay, stiffer, stronger, whatever it is. Just so that it takes more weight to compress it. Okay, let's see, is there any more? It's 2017. All right. Okay, so this is 2017. Okay, so now for today, I will just do physical science questions from the 2016 paper. Okay, hope you find it useful. Now, what's the key takeaway from the things that we have gone through so far? For me and my observation for 10 years, after 10 years of teaching people, let me just zoom it up. Okay, so what are some of the key takeaway that I have for you after doing the 2016 paper is number one, I think that you don't have to be too hard on yourself. Sometimes when you don't understand, you don't know the answer, I think it's perfectly okay. Just go and take a look at the solution, okay, and you learn from there. Don't be too hard on yourself. Now, if you're a parent, don't get overly worked up when they don't understand or they don't know how to do. I see that quite often. I mean, I don't see the parents doing it, but I hear it from the children, okay, from the students that, oh, my mom gets very, or my dad gets very worked up. They're like, oh, they cannot take it that I'm getting like 1 mark wrong. You know, I get 1 mark wrong, and because of my 1 mark wrong, I get scolding, etc. So that is actually detrimental. It's bad. Yeah, just be relaxed. You know, this science after all, it's not like some weird thing. You know, perfect. You're looking for perfection. Is it possible to get full marks? Yeah, I think it is possible, but with a lot of exposure. And another thing that a lot of people don't realize is that science nowadays is a lot of English comprehension. Okay, I can get some children who is perfectly logical, they understand all the science concept, but because the questions are so long, they're typically a 1 A4 size page kind of long. There's a lot of English reading comprehension involved, so English also plays a part. Okay, so at the end of the day, it's about a lot of exposure. It is a lot of practice. I think practice makes perfect. Okay, so I hope you enjoy watching this video. I actually enjoy making all these science video, math videos for you as well as your child, but most of you on Facebook are parents. So if you like what you see, just like us, the page, okay, like the page, give a comment, leave a comment, or share the video to whoever you think will love it, who will use it, who will need it. It will make me really happy to know that the videos are useful. And of course, send whatever comments you have to us. Okay, I feel free to let me know what other topics you want to do. I'll try my best to help everybody. Okay, so this is Mr. Ting signing off from Katong branch.